Okay, so let's start. So today we're starting the lecture on calculus. So calculus is basically the study of change. It's a branch of mathematics that deals with the study of change. So it deals with the study of change. So it deals with how variables, like let's say how one variable changes with respect to other variable. So I'll expand on this definition. Um, okay, so uh, let us take an example. So suppose, uh, I just said that calculus is a field of mathematics that deals with the study of change. Now, what do I actually mean with this? So suppose, for example, uh, you have a, let's say you have a cylinder. You have a cylinder. The base radius is r. So we know that the volume is equal to, uh, does anyone know the volume of a cylinder? No one.
Pi r square
Minus
h.
Greenwich.
Pi r square h, right?
Yes.
Okay, it's pi r squared h, and this is the height. So this is the volume, and this is the volume of the cylinder. So now what do I mean? Like, what do I mean? Like, how? So what I mean with change is, how will volume actually change with respect to the radius of the cylinder? This is one of the examples that you can think of. The other thing is, calculus actually provides a framework for modeling the system in which change, a system which changes. So you can actually predict how the system changes with respect to certain variables. This is what calculus is all about, right? You're all getting me, right?
Yes.
Okay. So right now we're just dealing with all the definitions and all, but okay, so how do you work with calculus? So let us have an example, right? So we'll have an example like how do we actually discover calculus? Let us look at the exercise. I have a not small, I'd say, but I have an exercise by which we can actually discover calculus ourselves. So let us look at that exercise. Okay. So suppose you have a let's say a race going on. This is a track, and like you have a race going on. There are three players. This is player one, and by the way, they're all racing on the same track, right? This is player two, and then we have, say, let's say player three, P3. They're all racing on the same track, but the trick is in this race, say we have a finish line. Let's say this is the finish line. uh, let's say the distance from the finish line from the origin, they all start, let's say, at origin. The distance is, let's say, 10 meters. 10 meters. So the rules of the race is, it is not the one who crosses the finish line will win. The one who crosses the finish line first, he will not win. The one who finishes the finish line with the highest speed, that car or that player will win the race. This is the twist of the race. So now I have some, okay. So now let's say we have some data like कि सारी कार्स ने किस डिस्टेंस, लाइक किस टाइम इंटरवल पे वो किस डिस्टेंस पे थे. from the origin, of course. So let us look at the data. So here we have player A. At t is equal to 1 seconds, the player A was at x is equal to 1 meters. All right. We have limited amount of data, all right, and yeah, the judges of the race, we are actually the judges of the race, so we have to judge who actually won the race. So we have to figure out who won the race based on this data we have. Is everything clear right now, right?
Yes.
Okay, so we have this data, and now we have to figure out who won the race. Okay, so we have at t is equal to 1 seconds, player A was at x is equal to 1 meters. Here x is measured from the origin. Note this. At t is equal to 9 seconds, we have x is equal to 81 meters. All right. Then we have at t is equal to 9.9, we have x is 98.01 meters, and so on. Okay. Does anyone know how can we find speed? We have to judge who won the race, right? So we have to figure out how do we calculate the speed at okay, wait. So I was wrong actually. I missed a part. Okay, the distance is actually 100 meters, not 10. It is 100 meters. The finish line is actually at a distance of 100 meters, not 10. 100 meters. All right. Wait, I again wrote 10. Okay, so this is 100 meters. Okay, can anyone tell me how do you like calculate speed? Anyone?
We divide the distance by time.
Okay, we divide the distance by time. Okay, so we have speed equals distance over time. We have speed equal distance over time. Okay, and what do we have to find? We have to find कि फिनिश लाइन पे सबसे ज्यादा स्पीड किसकी थी. ओके, let us first let us look at the data from the top. Like, let us take a overview of the data. We know that player A x is equal to 100 पे पहुंच गया at t equal to 10. Okay, प्लेयर बी ऑन दी अदर हैंड सेम टाइम पे एक्स इज इक्वल टू 100 पे पहुंच गया, मतलब दोनों ने फिनिश लाइन एक्स इज इक्वल टू 10 पे क्रॉस की. वेल, नॉट क्रॉस की, बट या दे बोथ रीच द फिनिश लाइन एट t इज इक्वल टू 10, राइट. प्लेयर सी ऑन दी अदर हैंड, वो सिर्फ 5 सेकेंड इनटू द रेस एंड ही फिनिश he crossed the finish line at t is equal to 5 seconds. Okay. सो अगर हम ऊपर ऊपर से देखें, प्लेयर बी को देखते हैं एक बार. प्लेयर बी ने टी इज इक्वल टू 1 पे उसका जो डिस्टेंस था फ्रॉम द ओरिजिन, इट वाज 10 मीटर्स, वाइल प्लेयर ए का सिर्फ 1 मीटर्स था, राइट. ओके, एट टी इज इक्वल टू 8 सेकेंड्स, जो प्लेयर बी का डिस्टेंस था फ्रॉम द ओरिजिन, इट वाज 80, वाइल प्लेयर ए का इट वाज 81 एट 9 सेकेंड्स. मतलब प्लेयर बी एट ऑलमोस्ट ऑल इंस्टेंट्स ऑफ टाइम प्लेयर ए से हमेशा आगे था. डज दैट मीन उसकी स्पीड ज्यादा होगी? We'll find out, all right. Okay, so and also at t is equal to 9, प्लेयर बी की जो डिस्टेंस थी ओरिजिन से वो थी 90, एंड एट टी इक्वल टू 9 प्लेयर ए की जो डिस्टेंस थी ओरिजिन से वो 81 थी. सो वी कैन सी के एट ऑल इंस्टेंट्स ऑफ टाइम प्लेयर बी हमेशा प्लेयर ए से आगे था, बट स्टिल दोनों ने टी इक्वल टू 10 सेकेंड पे क्रॉस लाइन को सॉरी फिनिश लाइन को क्रॉस कर दिया, राइट. ओके, वेल ऑन द अदर हैंड प्लेयर सी ने सिर्फ 5 सेकेंड्स में फिनिश लाइन क्रॉस कर दी. ओके, सो you guys told me that speed is actually distance upon time. So how do we find what is the speed at t is equal to 10? Okay, so let us substitute what do you say, the distance. So at t is equal to 10, our distance covered was 100. T equal 10 and x equal 100. So we have 100 by 10. and it's actually 10. So does that mean speed is actually 10 meters per second? Okay, so we found the speed for player A. Bingo. But is it actually 10? Let us see what is the speed. The speed is actually the average speed during the whole journey. Are we supposed to find average speed? No, we are not. We're supposed to find the instantaneous speed. The speed that player A has when it just reached the finish line. We're supposed to find that speed, the instantaneous speed at t equal 10 seconds, not the average speed over the whole journey. Is everything clear, right?
Yes.
Okay. So जो average speed थी during the whole journey, we found that it was 10 meters per second. Okay, let us do some calculations. We're actually given कि 9.99 seconds पे 9.999 seconds पे उसकी जो distance थी it was 99.980001. So अगर हम let us look at कि जो player A था ये player A है ये finish line है. This is the finish line. Wait, this is the finish line. And player A यहाँ पे let's say 9.999 t is equal to 9.999 और इसका distance है origin से 99.980001. अगर हम एंड दिस इज t इक्वल 10 पे वो यहाँ पे पहुंच गया, राइट? सो वो t इक्वल 10 पे यहाँ पे पहुंच गया एंड उसका डिस्टेंस था 100 फ्रॉम द ओरिजिन. सो अगर हम इस जर्नी के दौरान एवरेज स्पीड निकालें, could it be that हमारी स्पीड ज्यादा एक्यूरेट मेजर होगी? राइट, इट मेक सेंस ना, क्योंकि अगर हम शॉर्टर जर्नी में लाइक द जर्नी इज वेरी शॉर्ट एंड इस टाइम इंटरवल में अगर हम निकालें, so the average speed would actually turn out to be very close to instantaneous speed, right? Is everything clear now?
Yes.
Okay.
Yes.
So it makes sense कि सबसे पहले मैं एक बार रिवाइज करवा देता हूँ अभी तक हमने क्या क्या किया. हमने पहले सोचा कि हमने पहले तो पता किया स्पीड इज एक्चुअली डिस्टेंस ओवर टाइम. ऑल राइट, देन हमारा गोल ये था कि हमें फाइंड करना है कि सारे प्लेयर्स ने सारे प्लेयर्स में से किसकी सबसे ज्यादा स्पीड है एट द फिनिश लाइन. एंड नाउ हमने सोचा कि यार एवरेज निकाल लेते हैं, लेकिन यार एवरेज अगर हम निकाल देंगे देन दिक्कत ये पड़ेगी कि इट्स एक्चुअली नॉट द इंस्टेंटेनियस स्पीड, वो तो एवरेज स्पीड है. सो ओके, सो व्हाट डज इंस्टेंटेनियस स्पीड मीन? So suppose you're looking at a video. You're looking at a video of a car. You're looking at a video of a car, and at any moment you pause the video, right? You pause the video, and now at this instant, जो उस कार के स्पीडोमीटर में जो रीडिंग है, that is the instantaneous speed of the car. Is everyone getting my point?
Yes.
So instantaneous speed is actually the speed at the instant, which is obvious. And this is how you can imagine this. Suppose you're looking at a video of a car. Of course, it's moving. And the moment you pause the video, at that instant, in that frame, whatever the value speedometer is showing is the speed of the car. And this would be the instantaneous speed of the car. And our goal is actually to find the instantaneous speed. So what we're doing is we're shortening our time interval so that we can get a much better approximation, right? Okay, so let us do the calculations, shall we? Let us do the calculations. Um, so I'll remove everything. Okay. So now we have all understood how what I mean by instantaneous speed and why average speed would not work. So let us try to calculate something. Right? Okay. So I'll actually denote my average speed as this. This denotes average speed. Okay. Now the average speed actually turned out to be 10 meters per second. Let's see how far off we were from the average speed. Let us take the time interval between t is equal to 9.99 seconds and t equal 10 seconds. So we have t equal 9.99 seconds to t equal 10 seconds. So, okay. Now, what is the distance traveled in this time interval? We just have to do is, or what we have to do is just subtract, uh, wait, subtract this from 100. This is the distance traveled in this time interval. So can anyone do the calculation for me? Quick. Can anyone do the calculation for me?
Just a
Just a
second.
0.1999.
Yes, 0.1999. And what is this? This is the distance traveled in t equal 9.99 seconds to t equal 10 seconds. Okay, okay. So just to check if everyone understood whatever I said till this point, can you tell me why are we calculating this distance? Anyone?
To find the instantaneous speed.
Okay, so we're trying to find the instantaneous speed, sure. But let me remind you that we're trying to get as close to the instantaneous speed, right? Okay. So this is the distance traveled in this time interval. And what was the time interval? What is our time interval? Our time interval is from 9.99 seconds to t equal 10 seconds. So our time interval is actually 0.01. And what does this turn out to be? 19.99, right? Right? This turns out to be
Yes.
19.99. Okay. Okay, but we actually have a data जिसमें हम t equal 10 seconds के और पास हैं. So could it be that we can like get a better approximation? Let us try. Okay, note this value 19.99. I'll write it somewhere else. I'll write it कि हमारी speed 1 आई थी. I'm just denoting it by 1 so that it's our first best approximation. We'll try to get better and better approximations, right? So this is 19.99. And I'll delete everything. Okay. So now let us take a smaller time interval. Let's take this time interval. Okay, guys, do the subtraction for me. So we actually have t equal to 9.999 to t is equal to 10, and our distance traveled in this time interval is quick, guys. Okay, I'll do it. It's actually 0.019999, right? Can anyone check? It will turn out to be 0.019999. Okay. So let us try to find the average speed in this time interval. So our speed is actually 0.019999 divided by 0.999. Oh, I'm wrong. I'm wrong. 0.001. And what does this turn out to be? It turns out to be 19.999. So यहाँ पे it was a zero and our speed 2 is actually 19.999. Okay, we're getting closer. Okay, we're getting closer to the instantaneous speed. Okay, okay. So we're actually also given, I mean, कार जब फिनिश लाइन को क्रॉस करेगी, इट्स नॉट दैट कि कार फिनिश लाइन को क्रॉस करके उसी मोमेंट पे रुक जाएगी, राइट? सो वी ऑल्सो हैव कि एट टी इज इक्वल टू 10.001 कार की डिस्टेंस क्या थी? So let us try to calculate that. Everything is clear, right?
Yes.
Yes.
Okay. So now let us try to calculate. Um, Let us try to calculate the speed between these two time intervals. Like t is 10.01 to t is equal to 10. Oh, I'm wrong. I'm wrong again. Can someone correct me? Where am I wrong? Can someone correct me?
Will it be from 10 to 10.001?
Yes. So it's 10 to t is equal to 10.01. We're taking a larger time interval just so we can know like how far off will we be from the instantaneous peak. Okay. So x turns out to be, do the calculation. It turns out to be 0.2001, right? This is the distance traveled in this time interval. And so our speed, I'll say S3 is actually, oh, this is so simple. It's 20.00 divided by 0.01, and this turns out to be 20.01. So this is our speed 3. It's 20.01. It is getting a bit calculative because, guys, we don't know what calculus is. We're trying to figure it out. So, uh, so this is just an exercise for us to get started, right? So now we have S3. So now we can say one thing about instantaneous speed. Whatever the instantaneous speed is at t is equal to 10 seconds, whatever the instantaneous speed is, I'll denote the instantaneous speed as V instantaneous. Whatever the instantaneous speed is, we know for sure that it lies between S2 and S3, right? It has to lie between S2 and S3. Oh, and these speeds are in meters per second. Note this. So whatever speeds we're trying to calculate, the instantaneous speed we're trying to find is lying between 19.999 to 20.01. But we also have a time interval जिसमें a time interval very close to 10, which is 10.001. So between that time interval, from t is equal to 10 seconds to t is equal to 10.001, our distance traveled is actually 0.02001. So what is S4? S4 turns out to be 20.001. Okay. So now we also have a better approximation, 20.001. 20.001. So now we can also say that our v instantaneous, the instantaneous velocity will actually lie between 20.001. Is everything clear?
Can you repeat the last line?
Okay, I'll repeat what I just said. So हमने सबसे पहले S3 कैलकुलेट किया था. S3 इज बेसिकली 10 t इज इक्वल टू 10 सेकेंड से t इज इक्वल टू 10.01 सेकेंड्स के बीच में एवरेज स्पीड क्या थी. एंड t इज इक्वल टू 10 सेकेंड से t इज इक्वल टू 10.001 में हमने जो डिस्टेंस ट्रैवल किया था इस जर्नी के दौरान, इट वाज 0.020. Well, you can just subtract this, right? You can subtract 10.2001 from 100 to find the distance traveled in this time interval. तो हमने ये distance traveled in this time interval है, and we found the speed for basically the speed in this during this the average speed during this time interval, and it turned out to be 20.001. Is it clear?
Yes, yes.
Okay. So now we have okay, my bad. ये S3 के बारे में था. अभी जस्ट हमने S4 के लिए भी कैलकुलेट किया, and it turned out to be 20.001. So we have a better approximation. But instantaneous speed will actually lie, our instantaneous speed, V instantaneous, will actually lie between 19.999 to 20.001. Now, since we don't have enough data, what should we do? Can anyone suggest me how can I try to get to a specific value? I have that V instantaneous lies between these intervals. Can anyone suggest me a way to get to one specific value?
Maybe we can find the average of all of these speeds.
Right. So yes, since we don't have enough data, well, we actually have enough data, but this is the only data we're given. This is the only data we are given. So I think we should conclude, for the purpose of judging the race, that V instantaneous is nearly, I should say, equal to 19.999 plus, I'll take the average, 20.001 divided by 2. And so it turns out, wait a minute, guys. Right. So our V instantaneous is nearly equal to 20. And stick around, guys. We will actually find out that V instantaneous is actually equal to 20. We'll find out soon. So all this is done for player A. Now we have to do the same for player B and player C. So let us do that very quickly. For player A, we have concluded that the instantaneous velocity will be around 20 meters per second, right? Everything is clear, right?
Yes.
Done.
Um, okay. So now let us do that for player B. Can anyone find a pattern in in this data? Anyone?
10 times t is equals to x.
Right. So we see that t is actually x is actually 10 times t. So for player B, whenever we try to find the average speed, let's try to find the average speed. For the time interval between t is equal to 1 to t is equal to 10, the average speed turns out to be 100 minus 10 upon 10 minus 1, which is actually 10, right? So our speed turns out to be 10. Okay, but maybe it's just the average. I mean, it's still the average speed of the whole journey, right? We should maybe try to find the speed, the average speed during closer time intervals, closer to t is equal to 10. Uh, so let's try that. So let us take from t is equal to 9.99 to t is equal to 10, and we find that, okay, let me just erase this data. Okay. So for t is equal to for t is equal to 9.99 and 10, our speed comes out to be, anyone? What will be our speed?
Can you repeat the time interval?
Time interval is 9.99 and 10, between 9.99 and 10.
It's 1.
Is it?
Wait, let me read that.
Try again.
Zero 0.001.
No, you're far off. Array, speed क्या है? Speed is basically the distance traveled in this time interval over the uh, time interval.
It's
The
10.
Yes, it's 10. So it's 100, which is our final position, you can say, minus 99.9 over 0.01, which is 10, right? It's 10. Okay, but maybe we should try getting more closer to the time interval. Also, I didn't write here, but we said that V instantaneous for A is nearly equal to 20 meters per second. Although it's very slow considering it's a race, but sure. So our speed comes out to be 10, but it is for this particular time interval from 9.99 to 10. But we have data for time interval for time closer to 10, right? तो अगर हम टाइम इंटरवल लेते हैं 9.999 टू 10, इस टाइम इंटरवल में एवरेज स्पीड क्या आएगी? So I'll just say this is S1. S1 was 10. Let us find the average speed during the time interval 9.999 to 10. Okay, anyone, what will be our speed? It's easy. Our speed will be from t is equal to 9.999 to 10. Our speed will actually be 0.001 over 0.00. Wait, have I made a mistake? Am I making a mistake somewhere?
I think x should be equal to 99.99.
Right. So there's a mistake in our data. Um, It's actually 99.99, right? Okay, so what is our distance traveled? It is actually our distance traveled will be 0.01 upon 0.001, which is 10. So for this time interval also we're getting in speed of 10 meters per second. And if you guys will check, you will get the speed between 10 to 10.001 and 10 to 10.01. The speed will come out to be 10 meters per second only. What does this mean? This means that player B was always moving with speed 10 meters per second. So we can safely assume that between these time intervals, there was nothing sudden. You guys get me what I mean? So between these time intervals, there was nothing sudden in the there was no sudden change in the say there was no sudden change in speed of the player B. Then we can safely say that V instantaneous will actually be 10 meters per second. Also, हमने स्टार्टिंग में एक ओवरव्यू देखा था कि प्लेयर बी was always ahead of player A, but still player B की instantaneous speed at t is equal to 10 seconds was 10 meters per second. So you guys know that प्लेयर बी हमेशा प्लेयर ए से आगे था, हर एक टाइम इंटरवल पे प्लेयर ए से आगे था by a significant amount, you can say, and still उसकी instantaneous speed was 10 meters per second. Player B की I'll write this. This is for A, and V instantaneous comes out to be it is exactly equal to 10 meters per second. Can anyone tell me my assumption? What did I assume saying V instantaneous is 10 meters per second? Well, there was no. Uh, my voice is clear, right? Hello. Is everyone able to hear me? Everyone is able to hear. My voice is clear, right?
Yes.
Okay, sorry
Yes.
for the inconvenience. Tell me, like this is 10 meters per second. Was there any kind of assumption?
Instead of calculating, we just said all of the speeds will be 10.
Yes, but we said it for a reason. We assumed something. Um, there was one assumption. I don't know how to say it, but the assumption is very deep. The assumption is that between these two time intervals, there is nothing sudden. You get me? There is nothing sudden change. Uh, like say between let's say at t is equal to 9.9999 x.
Suhail, your screen is not visible.
Oh, is it? Oh, my bad. Okay. Oh, sorry. Thank you. Uh, okay. My screen is visible now, right? My screen is visible now.
Yes, just a second. It's loading.
Yes.
Yes, yeah.
Like, my screen is now visible. Okay. And audio is clear now.
Yeah.
Yeah.
Okay. So I was saying, okay, guys, can we wait a minute? Like, Wait a minute, guys. I'll be right back. Hello. My voice is clear now. I hope there's
Yes.
no like background noise.
No, it's clear.
Okay. So हम हाँ. So I was saying कि is there a sudden change? What I mean is we have assumed कि t is equal to 9.999 and t is equal to 10 seconds के बीच में there is no sudden change. What I mean by sudden change is say at t is equal to 9.999 the car actually travels something let's say the car travels a distance greater than 99.999. So this will actually break our pattern, you can say, or say this is actually a change that we have assumed is not taking place. So between t is equal to 9.999 and t is 10, there is no sudden change. Like कार ने अचानक से एक्सेलरेट नहीं किया होगा. अगर ऐसा होता है तो उसकी स्पीड बढ़ जाएगी, राइट? सो वी हैव अज्यूम्ड दिस. सो हमने प्लेयर बी की इंस्टेंटेनियस स्पीड निकाल दी है विच कम्स आउट टू बी 10 meters per second. Now let us quickly do that for player C. So ओके बाय द वे हमने जब देखा था डेटा ऊपर ऊपर से वी फाउंड दैट प्लेयर सी की जो स्पीड है सॉरी द प्लेयर सी हमेशा प्लेयर बी और प्लेयर ए से हमेशा आगे था, राइट? लाइक एट टी इज इक्वल टू 1 प्लेयर सी वाज ऑलरेडी एट एक्स इज इक्वल टू 4. सो इट मे बी दैट प्लेयर सी की स्पीड सबसे ज्यादा हो एंड प्लेयर सी मे हैव वन द रेस. लेट्स सी. सो if we see that t is equal to 1 to 2 seconds, the distance traveled is actually 76 between t is 1 to 2. So the speed is actually 76 meters per second, which is already greater than player A and B. बट मे बी आगे जाके उसकी स्पीड कम हो गई होगी. वी कांट जज ऑन द बेसिस ऑफ पास्ट में क्या हुआ था. वी वांट टू नो इंस्टेंटेनियस स्पीड क्या है. सो लेट्स सी कि इंस्टेंटेनियस स्पीड क्या है. सो अगर हम ऑल्सो हम यहाँ सब में यहाँ पे हमने t इज इक्वल टू 10 कंसिडर किया था, यहाँ पे भी t इज इक्वल टू 10 कंसिडर. हमने टाइम इंटरवल्स क्लोजर टू t इज इक्वल टू 10 ली थी क्योंकि द फिनिश लाइन वाज एट x इज इक्वल टू 100 meters. आई मीन फिनिश लाइन 100 पे, तो हमें वहां पर इंस्टेंटेनियस स्पीड फाइंड करनी थी. तो यहाँ पे t इज इक्वल टू 5 पे ही वो फिनिश लाइन पे पहुंच गया था. सो uh, uh, let us try to find the instantaneous speed between the time interval t is equal to 4.99 to 5. So what is the distance traveled? Anyone? Okay, it will come out to be 39 point, sorry, it will come out to be, my bad. It will actually come out to be 0.3996. So what is our speed? Guys, there's a mistake here. Actually, यहाँ पे t is actually equal to 16. This was mistake on my part. So from time interval t is equal to 1 to 2, the distance traveled was actually 12. So the speed come out to be 12 meters per second, which still is larger than the speed of player B. But ये average speed है during the journey from t is equal to 1 to 2 seconds. So like we cannot consider it. Maybe the speed decreases or increases. We don't know. हम past के basis पे judge नहीं कर सकते हैं, right? So हम instantaneous speed के close जा सकते हैं, as close as we please. So from t is equal to 5 to t is equal from t is equal to 4.99 to t is equal to 5, the distance traveled is this. So हमारी जो speed आएगी, it will be 39.96, right? Okay. Looking at this figure, we can already say that player C has definitely won the race, right? I mean, उसकी speed 10 से बड़ी 10 से ज़्यादा है, 20 से ज़्यादा है. It's 39.96. But for the sake of actually finding uski instantaneous speed, let us calculate the average speed during smaller and smaller time intervals. So at t is equal to 4.999 to t is equal to 5 seconds, the distance traveled will be 0.39996. Am I right? Check the calculation, guys. So our speed during this time interval, wait. So wait. Um, okay. So from t is equal to 4.999 to t is equal to 5, हमारी speed comes out to be, quick calculation tells us it's 39.996. Okay, we're getting closer to some value. We're getting closer to instantaneous speed. So let us try to find the instantaneous speed, like the average speed during a smaller time interval. जिसमें 5 is the, like 5 से लेके, let's say 5.001, we have the data, right? So that is the distance traveled in time interval from 5 to 5.001. The distance traveled is actually 0.40004. So our speed turns out to be 40.004. And doing the same for time interval 5 to 5.01, we can say that the speed will actually be 40.04. This is the speed during this time interval. So now we know that player C के लिए the V instantaneous is actually greater than 39.996 and less than 40.004. So is everything clear ना? अभी तक हमने क्या क्या किया है? It's very calculative, but I hope you get my point.
Yes.
Yes, yes.
So हमारी instantaneous speed जो आएगी वो इस interval के बीच में आएगी, but we don't have enough data, so it is safe to say that V instantaneous is nearly equal to, say we take the average. So the average will turn out to be 40 meters per second. So who won the race? Player C won the race. Okay, but we did so many calculations, but do we reach somewhere? Let us try to, uh, let us try to deduce from all the calculations. Have we like actually reached a conclusion? Let us try to infer, like what can we actually infer from all this example, all these examples that we've just performed. Experiments, sorry, all these experiments we have performed. So let us try to find out what can we infer from this. सो सबसे पहले हमने क्या किया, आई टेल यू गाइस, हमने सबसे पहले क्या किया। हमारे पास, हमको जानना था कि हमारे पास तीन कार्स थी, राइट। हमारे पास तीन कार्स थी, और रेस के रूल थे कि जो कार सबसे पहले फिनिश लाइन पे पहुंचेगी, अ, वो नहीं जीतेगी। जो कार सबसे पहले जो कार फिनिश लाइन पे पहुंचेगी विद हाईएस्ट स्पीड, वो कार जीतेगी, राइट। दिस वाज द ट्विस्ट ऑफ आर रेस। So this is A, this is B, and this is C. And what we did to find out the speed, we were still not able to get the instantaneous speed, but we got the best approximation possible, best possible approximation from the data we're given to like we can get very close to the instantaneous speed, right? So for player C, so what we actually did to get close to the instantaneous speed was we took smaller and smaller time intervals. This was our final this was the our T final, like the final position, and this was our initial position. So this gap is very small, and as smaller this gap gets, our average speed will tend to instantaneous speed. So as the time interval got smaller, our approximation our approximations our approximations uh, were closer to the actual speed. But still, जो हमने टाइम इंटरवल ली थी, our time interval was very small. It was nearly zero. Like तुमने notice किया था, it was usually the time interval was 0, 0, 1. And इस time interval पे player C की जो speed आई थी, player C की speed आई थी, it was 39. It was actually nearly equal to 40. For B, it was always 10, and for A, it was nearly equal to 20. Right? For
Yes.
So now, if you guys think, uh, डज इट मेक सेंस कि अगर हमने और स्मॉलर टाइम इंटरवल्स ली होती, we would have gotten better and better approximations, like, right? And there would come a point there would come a point that हमारा जो approximation था, it would be exactly equal to the actual speed. Okay, so ये सारी कैलकुलेशन से ज्यादा पता नहीं चलता, बट अगर हम इसको ग्राफ में प्लॉट करें, so maybe we can get somewhere. Okay, so let us see the graph. For player A, it t is equal to 9.999. हमारा x क्या आया था? हमारा x क्या आया था? Guys, stay with me. The class is getting a bit longer, but stay with me. So for player A, as we got closer and closer to 10, at time interval 9.999, हमारा x था 99.980001. Okay, so हमारा x था 99.980001. And at t is equal to 10, it was 100, and at t is equal to 10.001, it was nearly equal to like 10 point uh, 0.00001, something like that, right? It was something like that. So what we did was our speed was actually distance over time. This is our average speed, is distance traveled upon time taken. This is the definition of average speed, right? Time taken. But as this is delta x and this is delta t. But as delta t becomes smaller and smaller, so the process of becoming smaller and smaller, I'll call that tending to zero. Smaller and smaller is equivalent to saying tending to zero. This is the symbol for tending or approaching, tending or approaching. So as our delta t tends to zero, our approximations were better and better. As smaller as it got, approximation got better and better. So okay, so now let us see कि this is actually our delta t. This is our delta t, right? And this is actually our delta
Yes.
x. This is our delta x. This is the distance traveled in this time interval. And what we did was divide the two quantities. Okay. So let us see. If I draw a straight line, this is actually our delta x, and this is our delta t. And if you guys know enough mathematics, you know that how do you find slope between 2 points? Like let's say we are given 2 points. How do you find the slope of the line that passes through these points?
x2
What
minus x1 upon y2 minus y1.
exactly? That's what we do. हम क्या करते हैं स्लोप लेने के लिए x2 माइनस x1 अपॉन y2 माइनस y। क्या बोला तूने अभी वापस बोल।
x2 minus x1 upon y2 minus y1.
उल्टा बोल रहा है उल्टा। What we do is हम y2 माइनस y1 अपॉन
हाँ
x2
हाँ
माइनस x1 करते हैं। बट ऐसा क्यों करते हैं? Because it's the definition of slope. So what we did here, delta x by delta t, was actually the slope of these 2 points. This was actually the slope between these 2 points. Um, this is actually the slope between these 2 points, right? This is the slope. Now, as we get closer and closer, also हमने क्या किया है, एक बार तो 10 से कम, लाइक हमने पहले इनिशियल जो हमारा टाइम था वो एक बार 10 से कम लिया, और एक बार हमने फाइनल टाइम जो था टाइम इन सेकेंड्स वो हमने एक बार 10 से ज्यादा लिया। सो यहाँ पे इन दो पॉइंट्स के बीच में अगर देखें तो यहाँ पे भी ये डेल्टा टी है, ये डेल्टा t1 है, ये डेल्टा x1 है। डेल्टा ओके सो ये डेल्टा x1 है, ये डेल्टा x1 है, एंड ये भी ये डेल्टा x2 है। इस केस में हमने ये डिस्टेंस ट्रेवल, दिस वाज द डिस्टेंस ट्रेवल्ड इन दिस टाइम इंटरवल, एंड सो ये भी हमें इस पॉइंट और इस पॉइंट के बीच में स्लोप दे देगा। इज दिस क्लियर?
Yes.
Yes.
ओके, सो अभी तक हमने क्या क्या इन्फर किया है? ओके, आई थिंक गाइस class will not be class will not get over anytime sooner. I have some more things to discuss about, so you guys have to stay with me. So यहाँ पे हमने हमने क्या क्या इन्फर किया था? सबसे पहले अगर हम पीछे जाएं, हमने इन्फर किया कि जितनी छोटी टाइम इंटरवल हुई, हमारा स्पीड का अप्रोक्सीमेशन बेटर और बेटर होता गया। ठीक है, ये हमारा एक ये हमने इन्फर किया। सो हमारी एवरेज स्पीड वाज एक्चुअली स्लोली अप्रोचिंग इंस्टेंटेनियस स्पीड, राइट? सो नाउ अगर हम यहाँ पर भी ऐसा ही इस ग्राफ में भी सिमिलर प्रोसेस फॉलो करें, अगर हम एक काम करते हैं कि स्मॉलर और स्मॉलर टाइम इंटरवल्स लेते हैं, लेट्स से मैं 10 के बहुत पास वाली एक टाइम इंटरवल ले लेता हूँ। ओके, लेट मी जस्ट डिलीट एवरीथिंग। ओके, इट्स बेटर नाउ। सो अगर मैं काम करता हूँ कि मैं 10 के बहुत पास अगर एक टाइम इंटरवल अगर कंसिडर करूं, मैं लाइक वेरी क्लोज टू 10, से इट्स 9 say it's 9.99999 and so on. It's very close to 10. And so what will happen is, as our delta t tends to zero, our distance, ये जो हमारी distance है, the distance traveled in this time interval, delta x will also tend to zero. तो यार अगर मेरे को सबसे बेहतरीन अप्रोक्सीमेशन चाहिए, why not just do delta t equal zero? I mean, this would get me the best possible this would actually get me the instantaneous speed, ना? I mean, अगर speed equal delta x upon delta t है, और डेल्टा टी को बहुत छोटा करने पे हमारी स्पीड का अप्रोक्सीमेशन बेटर और बेटर हो रहा है, हम डेल्टा टी को जीरो ही क्यों नहीं कर देते? बट देन अगर हम डेल्टा टी जीरो कर देंगे तो हमारा डेल्टा एक्स भी जीरो हो जाएगा। सर सर स्पीड इज एक्चुअली अनडिफाइंड। सर स्पीड इज एक्चुअली अनडिफाइंड। So what do we do then? What should we do now? So what we do is we follow a limiting process, right? I mean, अगर मैं अपने टाइम को 10 के बहुत पास ले जा सकता हूँ सो दैट मेरी स्पीड बेटर, मेरा स्पीड का जो अप्रोक्सीमेशन है बेटर और बेटर होता जाए, तो अगर मैं उसको 10 पे ही रख दूंगा तो उसने डिस्टेंस तो कुछ कवर करा ही नहीं, और उसका टाइम इंटरवल भी जीरो है, तो उस टाइम पे उसकी स्पीड क्या 0/0 हो जाएगी यार। लेकिन 0/0 is undefined, right? 0/0 is undefined. We can't mathematically divide anything by zero. It's undefined. So what we do is we follow a limiting process. I'll come into this later, but everything is clear ना? अभी तक मैंने जो भी तुम्हें बताया है,
Yes.
मैंने अभी बहुत सारी चीजें पीसेस में तुम्हें बताई है, एंड एट लास्ट विल एड एवरीथिंग अप. सो नाउ लेट अस लुक एट प्लेयर बी. तुम यहाँ पे देख सकते हो कि एट टाइम इंटरवल 99 सॉरी एट टाइम इंटरवल 9 पॉइंट फ्रॉम बिटवीन टाइम इंटरवल 9.999 टू 10, यहाँ पे दिस इज द स्लोप the speed is actually the slope of the line between these 2 points. एंड ये था प्लेयर ए का ग्राफ. अभी हमने देखा ये प्लेयर ए का ग्राफ था, ये प्लेयर ए का ग्राफ है, एंड ये प्लेयर बी का ग्राफ है, एंड मैंने साथ में प्लेयर ए का ग्राफ भी बनाया. सो अगर हम प्लेयर बी के ग्राफ को देखें, इट्स अ स्ट्रेट लाइन, राइट, एंड इट्स अ स्ट्रेट लाइन अलोंग विद and what property does a straight line have? Anyone? Does anyone know a like special property of straight lines?
It is unending.
Okay, but I mean, I can define any curve which is ending. Like y is equal to x squared. It's also an unending curve. A line has a property that it has constant slope. The slope remains constant, right?
Yeah.
This is the property of line. And हमने जब player B का graph plot किया, we note that it's a straight line, and so इसका slope is constant. And okay, what was one of the things that we inferred from our graph? We inferred that हमारी speed जो थी, speed between T1 and T2, जो हमारी speed थी, it was actually the slope of line passing through the point interval, points जिसके interval थे x1, t1 and x2, t2, right? Slope of line which passes through these 2 points, ये हमारी स्पीड थी. इस केस में तो स्लोप कांस्टेंट है, इसका मतलब क्या हुआ? स्पीड इज कांस्टेंट. सो वी वर एक्चुअली राइट कि इसकी जो इंस्टेंटेनियस स्पीड होगी किसी भी पॉइंट पे, v instantaneous will remain constant, and we actually found out that it's actually 10 meters per second, right?
Yeah.
Okay. Now, similar study can be done on the graph of player 3, but now I'll stick to like let us study more about the graph. But I'll not talk about particularly player A. Let's study more about this specific graph of x is equal to t squared. When we like backtrack the behavior of x versus t for player A, it turned out कि उसका graph was the graph of x is equal to t squared. I'm sure you might have noticed this as well, now, because
Yeah.
every like t का square was equal to x. You guys may have noticed 10 के लिए 100, 9 के लिए 81, 9.9 के लिए 9, 8.01.
Yes.
So now हम एक काम करते हैं, हमें अब पता चल गया है कि इसका जो जो ग्राफ है प्लेयर ए का, इट इज एग्जैक्टली इक्वल, इट इज एग्जैक्टली दिस ग्राफ. दिस इज द एग्जैक्ट ग्राफ. So now since we have exact graph, we should be able to find the instantaneous speed. So let us attempt to find the instantaneous speed. हमने approximate किया था ना instantaneous speed, just like for judging the race, we approximated the instantaneous speed to be 20 meters per second, right?
Yes.
ये हमारा approximation था, but it will turn out that the instantaneous speed is actually literally equal to 20 meters per second. The instantaneous speed will actually turn out to be 20 meters per second. Wait a minute, guys. Okay. So now uh, we are done calculating. Let us try and use our brains. So what we want to find is instantaneous speed, v instantaneous at t is equal to 10 seconds, uh, where x is equal to 100 meters per second. Okay, no. X is 100 meters. My x is 100 meters. So this is the point, and we inferred from all our experiments that as delta t tends to zero, our approximations becomes better and better. So now इस केस में अगर हम टाइम इंटरवल लेते हैं वेरी क्लोज टू 10, then our speed will just be the slope. We also inferred that our speed is actually slope. I made these 2 points very clear, right?
Yes.
We have all derived this ourselves, na? We have all derived this ourselves. So it should be very clear that speed will actually be the slope of this curve. Why would it be the slope of this curve? Because what we're doing is we are dividing the change in x to the change in delta t, and which essentially is defined to be the slope of the line that passes through these 2 points. So it must mean that our speed is actually the slope of I'll say this is point A and this is point B, or I should say this is point A and this is point B. Our point A is okay. If it's not clear, then point A का जो coordinate है, you can say it's 10, 100. This is the coordinates of A, right? These are the coordinates of A. Okay. So speed is actually slope of line that passes through these 2 points. And we said that as our delta t tends to zero, our approximation gets better and better. But then we tried putting delta t equals zero and we failed miserably because we don't know what 0 by 0 means. What is 0 by 0? So let us use our brains now. We have, as we get delta t to zero, what we do is we're actually uh, finding out the slope between point A and B. Okay, let me zoom in. Okay, let me zoom in. As our delta t tends to zero, we are actually finding out okay, let me use a different color. We're actually finding out the slope of this line, right? And so as our delta t tends to zero, this point B will actually move towards A. Uh, okay. So this point B will actually move towards A. So ये हमारा जो point B था, it will slowly move towards A. This will move towards A. And so in the limiting process, it essentially becomes tangent uh, tangent to A. Our line actually becomes tangent to A. We will find a similar conclusion. Say if we chose this point C with some time, let's say 10 seconds से ज़्यादा पर अगर अगर हम हमारी टाइम इंटरवल लेते हैं तो हम ऐसा भी कर सकते हैं कि दिस पॉइंट एक्चुअली मूव्स टुवर्ड्स ए एज आर डेल्टा टी टेंड्स टू जीरो दिस पॉइंट विल एक्चुअली मूव टुवर्ड्स ए राइट um this point will actually move towards a so now it will essentially become the tangent to a the line BA actually tends to tangent at A. Okay, can anyone tell me what is the definition of tangent? Can anyone
A,
tell me what is the definition of tangent?
a line that intersects a point at exactly one point.
Okay, this is actually, I'd say, a wrong definition. The tangent, the tangent to A is
It's
actually
a line touching one point of the circle and passing through it, making a 90-degree angle with the center.
okay, but where do we have a circle in this picture? We don't.
Oh, sorry. Well,
No, no, you're right, but you're right only for circles. Okay, so it turns out that this is actually the definition of tangent essentially comes from this argument only. Okay, what is our argument? Our argument is that कि जैसे डेल्टा टी ये जो टाइम का गैप है टाइम इंटरवल गैप जैसे जैसे कम होगा ये पॉइंट बी पॉइंट ए के बहुत पास आ जाएगा एंड सो ये जो लाइन बनेगी लाइन पासिंग थ्रू बी एन इट विल ओनली पास थ्रू ए क्योंकि पॉइंट बी तो ए के बहुत पास आ जाएगा सो इन द लिमिटिंग प्रोसेस द लाइन विल ओनली पास थ्रू ए बट देयर इज वन कंडीशन द कंडीशन इज दैट कि हमारा जो ग्राफ है वेट इट्स वेरी मेसी it's very messy let us look at this graph and let me just delete this line okay. Let us look at this graph so हमारा जो पॉइंट बी है और ये हमारा पॉइंट सी है जैसे जैसे ये पॉइंट इसके पास आ रहे हैं जो लाइन पास होगी ये हमारा पॉइंट ए जो लाइन पास होगी ए और बी से जैसे जैसे पॉइंट ए और बी के पास आएंगे ये लाइन सिर्फ ए से पास होगी और इस नेबरहुड में नोट द वर्ड आई एम यूजिंग इस नेबरहुड में कभी भी ये लाइन इंटरसेक्ट नहीं करेगी बट इट कैन हैपन कि ये लाइन आगे जाके कर्व को इंटरसेक्ट कर ले इट कैन हैपन the definition of the word tangent essentially comes from this argument कि जैसे जैसे बी ए की तरफ आएगा the line segment will will cease to only pass through A because point B or point C are infinitely close to A, right? And so this is the definition of tangent कि neighborhood में वो कभी intersect नहीं करेगा in this neighborhood वो curve को एक ही point पे touch कर रहा है note the word I am using in this neighborhood so अगर ये हमारा ग्राफ है so ये लाइन इस पॉइंट को ये लाइन इस कर्व को इसी पॉइंट पे टच कर रही इट कैन हैपन दैट आगे जाके इट इंटरसेक्ट्स द कर्व है ना ये अपना कर्व है दिस इज आवर कर्व दिस इज आवर कर्व इन रेड इट कैन हैपन दैट लाइन आगे जाके इंटरसेक्ट कर ले बट इन द नेबरहुड इट वोंट इंटरसेक्ट इट शुड नॉट इंटरसेक्ट एंड दिस इज द डेफिनेशन ऑफ टेंजेंट all right so now comes the part where we try to okay we got the concept na ki what we should do is we should try to follow a limiting process कि हम B को slowly A की तरफ से B को A की तरफ अप्रोच करवाएं so that हमारी स्पीड बेटर एंड बेटर हमारी स्पीड का अप्रोक्सीमेशन बेटर एंड बेटर जाए राइट so now let us try to actually find the speed Everyone got my idea ना?
Yes, yes.
Okay. हमारा what was the graph x is equal to t squared, right? हमको क्या फाइंड करना है? स्लोप। स्लोप फाइंड करना है। वाई स्लोप क्यों फाइंड करना है? क्योंकि वो स्पीड के बराबर है। स्लोप क्या आएगा? हमें स्लोप फाइंड करना है बिटवीन पॉइंट ए एंड सम पॉइंट सी, बट पॉइंट सी इज इन्फिनिटली क्लोज टू पॉइंट ए। सो what will be the slope? Slope is y2 minus y1 upon x2 minus x1. So it's actually what is y2 here? Let's say c is y2. y2 हम बोलते हैं कि okay, wait. Let's say this is actually our delta t. This is delta t, and this is delta x. So our y2 is delta x by delta t. Okay, and it is also the y2. It's also y2 minus y1 upon x2 minus x1, right? Everyone knows this ना? तो पॉइंट सी का y कोऑर्डिनेट क्या है? लेट्स से ये हमने डेल्टा x बोला, सो इट इज, और ये डिस्टेंस तो x है, राइट? ये तो डिस्टेंस x है, सो इट इज एक्चुअली x, वेट अ मिनट, ओके, यस। तो ये डिस्टेंस x है, तो इसका y कोऑर्डिनेट क्या आएगा? सॉरी, ये आई शुड से टाइम इंटरवल में, या फिर इट्स फाइन ऐसे कि ये अगर टाइम इंटरवल डेल्टा टी है, ये अगर टाइम इंटरवल टी है, तो x इज इक्वल टू टी स्क्वायर, राइट? बट यहाँ पे दिस इज टी प्लस डेल्टा टी। ये टाइम, ओके वेट, आई एम कंफ्यूजिंग यू गाइस एक्चुअली। टी इज इक्वल टू 0 से 10 तक टाइम इंटरवल अगर हम टी, लेट्स से इसको हम टी से डिनोट करें, देन दिस इज टी स्क्वायर्ड, टी प्लस डेल्टा टी का स्क्वायर। लेट मी रिपीट माई सेल्फ। लेट्स से हम 0 से t इज इक्वल टू 10 की टाइम, जो टाइम इंटरवल है, वी नो दैट इट्स 10, बट फॉर द पर्पस ऑफ जनरलाइजिंग दिस, लेट्स से दिस इज t, देन वी से दैट हम 10 के थोड़ा आगे डेल्टा t टाइम इंटरवल को अगर देखते हैं, तो x क्या आता है? डेल्टा x हमारा डेल्टा x आता है। सो हमारा फंक्शन क्या है? टी, x इज इक्वल टू टी स्क्वायर, दिस इज आवर फंक्शन। सो यहाँ एट दिस मोमेंट t की वैल्यू क्या होगी? t की वैल्यू होगी t प्लस डेल्टा टी। तो हमारा x प्लस डेल्टा x इज एक्चुअली t प्लस डेल्टा टी का होल स्क्वायर, विच इज t स्क्वायर प्लस 2t डेल्टा टी प्लस डेल्टा टी स्क्वायर, राइट? इज दिस क्लियर? इट्स क्लियर ना?
Yes.
Can you elaborate how x plus delta x is equals to t plus delta t whole square?
ओके, सो या आई मे हैव कंफ्यूज यू गाइस। ये हमने पॉइंट सी लिया है, अभी ये पॉइंट सी है, तो हम 10 के आगे डेल्टा टी टाइम अगर आगे जाते हैं, तो x जो है डेल्टा x बढ़ता है। दिस इज डेल्टा x। सब यहाँ तक टोटल टाइम इंटरवल, टोटल टाइम क्या है? यहाँ से यहाँ तक टोटल टाइम क्या है? t प्लस
T,
डेल्टा टी।
yeah,
इसके करस्पॉन्डिंग पॉइंट सी तो ग्राफ पे ही लाई कर रहा है ना, तो पॉइंट सी का y कोऑर्डिनेट क्या होगा? t प्लस डेल्टा टी का होल स्क्वायर, क्योंकि अपना ग्राफ तो x इज इक्वल टू टी स्क्वायर का है ना,
yeah.
ठीक है? तो अपना
Hmm.
पॉइंट सी से हमने x प्लस डेल्टा x आ गया। x क्या है अपना? x इज एक्चुअली टी स्क्वायर।
Yeah.
सो कैन वी कैंसल x विद टी स्क्वायर, क्योंकि x तो टी स्क्वायर के बराबर है।
Yeah.
डेल्टा x बाय डेल्टा टी क्या आता है? डेल्टा x बाय डेल्टा टी आता है 2t प्लस डेल्टा टी। नाउ कम्स आवर आर्ग्यूमेंट कि हमें डेल्टा टी को इतना स्मॉल लेना है कि हमारी स्पीड का, ओ ओ बाय द वे, डेल्टा एक्स बाय डेल्टा टी क्या है? अपनी एवरेज स्पीड है। एवरेज स्पीड है, राइट। ये तो एवरेज स्पीड है बिटवीन 10 से लेके 10 प्लस डेल्टा टी। इस टाइम इंटरवल के बीच में, डेल्टा टी टाइम इंटरवल के बीच में, ये हमारी एवरेज स्पीड है, विच इज 2t प्लस डेल्टा टी। हमें क्या चाहिए? हमें चाहिए इंस्टेंटेनियस स्पीड, राइट। हमें इंस्टेंटेनियस स्पीड चाहिए। सो वी कैन से दैट 2t प्लस डेल्टा टी इज द एवरेज स्पीड। हमें इंस्टेंटेनियस स्पीड चाहिए, तो हम चाहते हैं कि डेल्टा टी को इतना छोटा कर दो कि हमारी जो स्पीड है ना, वो इंस्टेंटेनियस स्पीड बन जाए। ये बन जाए इंस्टेंटेनियस स्पीड। और अगर डेल्टा टी को अपन छोटा और छोटा करते जाएं, तो अपनी जो स्पीड आती है ना, अपनी स्पीड क्या आ जाती है? 2t। जैसे जैसे अपन डेल्टा टी को छोटा करते हैं, हमारी स्पीड 2t बन जाती है, क्योंकि डेल्टा टी का टर्म लाइक टेंडिंग टू जीरो है। आर यू
हाँ.
गेटिंग माई पॉइंट?
Yes.
हमारी स्पीड क्या है? हमारी स्पीड है 2t प्लस डेल्टा टी।
हम्म.
हम चाहते हैं इसको सबसे, इसका बेहतरीन अप्रोक्सीमेशन, और से हमें एग्जैक्ट वैल्यू चाहिए। डेल्टा टी को जीरो पुट कर सकते हैं क्या? डेल्टा टी को जीरो पुट कर सकते हैं क्या?
हाँ.
लेकिन अगर हम डेल्टा टी को जीरो पुट करें, देन मैथमेटिकली डेल्टा टी को जीरो पुट करें तो हमारा जो डेल्टा एक्स आएगा ना, वो भी जीरो आ जाएगा। सो हमारी एवरेज स्पीड वुड बी जीरो बाई जीरो। इंस्टेड व्हाट वी डू इज, हम डेल्टा टी को स्टिल जीरो पुट करेंगे, बट but what we do is we follow a limiting process. Now what is a limiting process? ये हमारी स्पीड है। can you guys like understand कि ये, this is a function of speed and time. Sorry, this is the function this is speed as a function of time, right? and
Yes.
and हमें बेस्ट पॉसिबल अप्रोक्सीमेशन चाहिए। डेल्टा टी को अगर मैं 0.0000 एंड सो ऑन इतना छोटा बना दूं, तो हमारी जो अपनी एवरेज स्पीड आएगी ना, वो जैसे ही डेल्टा टी को मैं जीरो के करीब ले जाऊं, एज इट टेंड्स टू जीरो, हमारी जो स्पीड आएगी, व्हाट विल इट टेंड टू? इट विल टेंड टू 2t, which is
Yes.
actually our instantaneous speed. This is actually our instantaneous speed. Okay guys, so हमारी इंस्टेंटेनियस स्पीड फाइनली आ गई। क्या है हमारी इंस्टेंटेनियस स्पीड फॉर प्लेयर ए? फॉर प्लेयर ए हमारी स्पीड आ गई 2t, एंड ये स्पीड है इंस्टेंटेनियस स्पीड। ये स्पीड है इंस्टेंटेनियस स्पीड विच इज इक्वल टू 2t। ओके गाइस, हमें क्या निकालना था? एट t इज इक्वल टू 10 स्पीड क्या आएगी? पुट t इज इक्वल टू 10 एंड यू गेट स्पीड क्या आ जाती है? 20। सो इंस्टेंटेनियस स्पीड इज एग्जैक्टली इक्वल टू 20। इट्स ये 20 से कम भी नहीं है, 20 से ज्यादा भी नहीं है, इट्स एग्जैक्टली इक्वल टू 20। एंड the points that you guys should deduce from here is, tangent की definition यहां से derive होती है। tangent की definition हम calculus से derive करते हैं। what we just did here is, discover calculus, because this is actually a major part of calculus, and this part of calculus is called differential calculus. Differential calculus में we actually deal with the instantaneous rate of change. Okay, can any one of you explain what if I say in instantaneous rate of change, how is change happening in an instant? I mean, for something to change, there must be a time interval, na, for it to change. So what do I mean by instantaneous rate of change? Can any one of you tell me? Vihan, any thoughts?
I'm processing but unable to answer, I think.
No worries. Okay. Uh, So instantaneous speed is more of an what do you say? It's an oxymoron. I mean, sorry, what instantaneous rate of change seems like an oxymoron, right? I mean, how is it instantaneous as well as change? What was हम हमें instantaneous speed निकालनी थी. Speed is क्या? Speed, what is speed? Rate of change of distance with time, right? And we said कि हमें instantaneous speed निकालनी है. So that means हमें instantaneous rate of change निकालना है of distance with time. अबे अब अगर स्पीड अगर चेंज हो रहा है तो वो इंस्टेंटेनियस कैसे? It must be, there must be a time interval associated to it. Can any one of you guys tell me? Okay, remember that one example I gave you. Imagine you're watching a video of a car. You're watching a video of a car, right? And यहाँ पे there's an speedometer. So car चल रही है, speedometer की reading change हो रही है, but the moment you pause the video, that reading is the instantaneous rate of change of distance with time. That is the instantaneous speed. So the term seems like an oxymoron, but it is not. It is not actually an oxymoron. So it does actually make sense if you think about it, right? Does it make sense, Vihan and Fatima?
I'm not sure, it's complicated.
Okay.
Like, can you again tell the concept why it is not oxymoron? The relation between instantaneous and the rate of change you explained just now.
Okay. So oxymoron, yes. Instantaneous rate of change seems like an oxymoron. Why? Because यार एक तो वो instantaneous है, मतलब कि at this moment, but still we are trying to find the rate of change. How is it gonna change at that instant, right? But that's wrong. I gave you an example. Suppose let's say uh, you're watching a video of a car. This is a video of a car which is moving, and you're able to like see its speedometer. Speedometer shows you the reading of the like the instantaneous speed, right? अगर कार 80 किलोमीटर पर आवर से चल रही है तो उसका स्पीडोमीटर 80 किलोमीटर पर आवर की रीडिंग शो करेगा. अगर तुमने घर बैठे बैठे इस वीडियो को पॉज कर दिया तो क्या स्पीडोमीटर की रीडिंग जीरो हो जाएगी? नहीं, स्पीडोमीटर तो उस टाइम फ्रेम में पॉज्ड है, राइट? इस इंस्टेंट पे At this instant जो speedometer की reading है, let's say it's 80 kilometers per hour, then this is the instantaneous speed. You got it? Even though हमने
Yeah.
इस टाइम हमने इस वीडियो को पॉज कर दिया, स्पीडोमीटर की रीडिंग चेंज नहीं हो रही है इस इंस्टेंट पे. जो स्पीडोमीटर की रीडिंग है, दैट इज द इंस्टेंटेनियस स्पीड. This is a good way of thinking about instantaneous rate of change. I just gave you, I found this example very good. Like, it's good to imagine, right? It's into it, it's very into it,
Yeah.
right? Okay. So now, what we just found was, there were many terms which I used. Let us try to deal with them one by one. I use the word limit. I use the word limiting process. I use the word by the way, guys. I did not use any formulas of maybe you guys may know some formulas for differentiation or whatever, but we tried to discover it all from scratch, right? And I hope everything made sense. Even after the class, you can all this data. I just made it all up, and you can try this at home, and you'll get a much better understanding. You can try plotting the graphs and all that. And by the way, guys, the graph of player C is actually a parabola too, and the equation is x is equal to 4t squared. And by a similar method, you can try to find कि इसकी instantaneous speed as a function of t क्या होगी. We were able to find कि इसकी instantaneous speed is nearly equal to 40 meters per second. So it's I leave this as an exercise for you to figure it out. I already derived कि instantaneous speed x is equal to t squared के केस में हमारी जो instantaneous speed थी, it was actually 2t. This is exactly equal to the instantaneous speed. Nothing more, nothing less. Now, okay, let us deal with the term that I used. It was limiting process. What do I mean with limiting process? What is limits? So first, so we have functions in mathematics, right? So what limit tells us? It tells us that how will the function, how will the function behave as say x tends to something, x tends to any value. So how will that function behave? What will be the effect? No, I'll not say effect, but I'll say how will the function behave as, okay, what I mean is, take a function, say y is equal to 3x. As x tends to 5, you will notice that y की वैल्यू भी इंक्रीज होगी. जैसे जैसे तुम x की वैल्यू इंक्रीज करके या डिक्रीज करके 5 तक लाने की कोशिश करोगे, यू सी दैट y की वैल्यू भी इंक्रीज होगी या डिक्रीज होगी फ्रॉम टू 15. जैसे जैसे x 5 की तरफ बढ़ेगा, y 15 की तरफ बढ़ेगा. Does it make sense? I mean, it totally makes sense now. This is what I say is a limiting process. So the limiting process which we followed was, we said that जैसे जैसे डेल्टा टी 0 की तरफ जाएगा, हमारी जो एवरेज स्पीड आएगी वो किसकी तरफ जाएगी? इंस्टेंटेनियस स्पीड की तरफ, राइट? So this is what I mean by limiting process. Is it clear?
Yes.
Okay.
Yes.
Okay, so let us discuss something. Let us discuss about infinities and what are infinitesimals. So let us take a graph. Let's say I take a graph of x cube. Let us say I take a graph of x cube. I take a graph of x cube. Um, okay. Let us say I take a graph of x cube. How does graph of x cube look like? It looks like this, right? This is the graph of y is equal to x cube.
Yes.
Now, what we found was that we can find the slope at this point. How can we find a slope at this point? By following a limiting process. And our limiting process was we take a point, this is x and this is y. We follow a limiting process and we take a point, uh, we take we take this point so that it's just अगर हम इस point, let's say ये x है और ये y है, when we take a point so that वो यहाँ से डेल्टा x दूर है एंड इसमें जो चेंज आया है y की वैल्यू में वो है डेल्टा y. एंड नाउ we have worked this all out now. We know that the slope is actually delta y by delta x, and as delta x tends to 0, the line tends to become tangent, and the definition of tangent comes from this only. And so our slope essentially becomes the slope of the tangent. So we say the slope of the tangent is actually slope of tangent. Slope of tangent is actually uh, delta delta y by delta x. And when I say we're following a limiting process, we say that the limit of delta x tending to 0. This means that we're actually following a limiting process. So this will essentially give us the exact slope of the line that is tangent to this curve. And we denote this by dy by dx. Right? This is just the definition. हमने this is the way of representing this is just like I'm just saying this is a limiting process, and the value of this limit is the tangent of this slope, right? This is clear now.
Yes.
Okay.
Yes.
Okay, so now what is left is let me tell you guys about some terms. We have terms like infinity. We come across terms like infinity, maybe in our day-to-day lives, but what exactly is infinity? Let me remind you guys that infinity is actually a relative concept. This is actually a relative concept. This always depends on context. right? It will always depend on the context. So, for example, can anyone tell me how many natural numbers are there? How many natural numbers are there?
Infinite.
Infinite.
Infinite. How many integers are there?
Infinite.
Okay. Suppose we want to compare that. Uh, Suppose we want to compare the number of elements in natural numbers, the set of natural numbers and the set of integers. सब ज्यादा elements किसके होंगे?
Integers.
Integers. No. दोनों में same number of elements है. दोनों में same number of elements है.
How?
Okay. So so I'll define that we can a set is countable. A set is countable if we are able to know the first element, we are able to define the second element, and we are able to assign each element a integer, a unique integer. It may go on forever, but that is the definition of a countable set. A countable set is a one जिसके हर एक एलिमेंट के को तुम एक नंबर असाइन कर सकते हो. इट मे बी इन्फिनिट, लाइक तुम इनफाइनाइट नंबर्स असाइन कर सकते हो, लेकिन you should be able to know कि first element कौन सा है, second element कौन सा है. Basically you can make a list of all the elements and you are able to identify each element with a unique integer. This is what I say would be the definition of a countable set. नेचुरल नंबर का सेट काउंटेबल है क्योंकि तुम इसके हर एक एलिमेंट को एक इंटीजर असाइन कर सकते हो. सो इट दैट सो बाय डेफिनेशन इट्स काउंटेबल. सो सिमिलरली हम z के लिए भी कर सकते हैं. नाउ आई सेड कि दोनों में सेम नंबर ऑफ एलिमेंट्स हैं. अगर इसमें इनफाइनाइट है तो इसमें भी वो ही इनफाइनाइट होंगे. आई मीन द द नंबर ऑफ एलिमेंट्स इन z and n आर सेम. हाउ? ओके. सपोज मैं नेचुरल नंबर्स को डिवाइड कर सकता हूँ इवन में. सो लाइक लेट्स से 2, 4, 6 एंड सो ऑन, एंड ऑड में 1, 3 एंड सो ऑन. जेड, अब क्या करते हैं अपन, जेड में जो सारे नेगेटिव नंबर्स हैं, लेट्स से -1, -2, -3 एंड सो ऑन, then comes 0, then comes 1, 2 and so on. Let us do one thing. हम ये हम क्या करते हैं कि सारे नेगेटिव नंबर को एक इवन नेगेटिव इंटीजर्स को एक इवन नंबर असाइन कर देते हैं. तो लेट्स से मैंने -1 को 2 कर दिया, -2 को मैंने 4 नंबर असाइन किया है, -3 को मैंने 6 नंबर असाइन किया है, 0 को मैंने लेट्स से 1 असाइन कर दिया, 1 को मैंने 3. अब मैं जो पॉजिटिव नंबर्स हैं, पॉजिटिव इंटीजर्स हैं, उनको ऑड नंबर असाइन करता हूँ. 2 को मैंने 5 कर दिया. तो मैं हर एक इंटीजर को अगर वो नेगेटिव इंटीजर है तो उसको मैंने एक इवन नंबर असाइन कर दिया. अगर वो एक ऑड इंटीजर है, सॉरी, अगर वो एक पॉजिटिव इंटीजर है तो मैंने उसको एक ऑड नंबर असाइन, ऑड नेचुरल असाइन कर दिया. मतलब कि हर एक इंटीजर के करस्पॉन्डिंग एक यूनिक नेचुरल नंबर असाइन किया गया है. डज दैट नॉट इम्प्लाई कि दोनों की साइज सेम है?
Yeah, kind of.
इट डज ना. इट डायरेक्टली इंप्लाइज दैट दोनों की साइज सेम है. मैंने -1 को 2 असाइन किया, -2 को 4 असाइन किया एंड सो ऑन. तो जितने भी नेगेटिव नंबर्स हैं उतने ही मैंने इवन नंबर असाइन किए हैं. जितने ही नॉन नेगेटिव नंबर्स हैं उनको मैंने ऑड नेचुरल नंबर्स असाइन कर दिए। इन दोनों को मिलाएंगे तो जी बनेगा, और इवन नंबर और ऑड नंबर्स को मिलाएंगे तो नेचुरल नंबर का सेट बनेगा। मतलब दोनों में सेम नंबर ऑफ एलिमेंट्स हैं। बट ओके, नाउ टेल मी कि अ, अगर मैं एक सेट ई डिफाइन करता हूँ, 2 4 6 8 एंड सो ऑन, infinite number of elements, and n 1 2 एंड सो ऑन, ये नेचुरल नंबर्स का सेट है, ये सारी इवन नंबर्स का सेट है। दोनों में से क्या लगता है तुम्हें सबसे ज्यादा एलिमेंट्स किसके होंगे? टेक अ गेस।
इक्वल होंगे।
इक्वल होंगे?
नहीं, नेचुरल नंबर ज्यादा होगा।
ओके, एक्चुअली इक्वल होंगे।
ब्रो।
Why? Because to every natural number, I can assign an even number times 2. इसका times 2। 2 को मैंने आई कैन असाइन एन इवन नंबर, उसका टाइम्स 2। 3 को मैंने असाइन किया, इसका इवन नंबर टाइम्स 2। तो बेसिकली ये मैंने इसको 2 असाइन किया, इसको 4 असाइन किया, इसको 6 असाइन किया। तो सारे नेचुरल नंबर्स को मैंने एक इवन नंबर के साथ असाइन कर दिया। इसका मतलब दोनों के सेम नंबर ऑफ एलिमेंट्स होंगे। Does it make sense, Vihan?
Yes, I think.
Okay. So what I mean is कि you should think of infinity as unintuitive. You won't be able to I mean, you won't be able to work it out intuitively. It will never work out intuitively. You should have a mathematician's intuition. You won't be able to uh, work it all out with natural intuition. You won't be. So, so we know that we can now like verify that infinity is a relative term. But there is one more thing I want to talk about is that uh, can we also show that the set of rational numbers x, so that x equal p upon q, where q is non-zero, p comma q belongs to integers, uh, ये जो सेट है, इस सेट के जो एलिमेंट्स होंगे एंड जो नेचुरल नंबर्स के एलिमेंट्स होंगे, उसमें से सबसे ज्यादा एलिमेंट्स किसके होने चाहिए?
इक्वल होंगे।
इक्वल होंगे?
नहीं।
कैन यू प्रूव अनइक्वल होंगे?
आ, क्योंकि दो नेचुरल नंबर के बीच में देर ऑलरेडी सो मेनी रैशनल नंबर्स, तो रैशनल नंबर अल्टीमेटली ज्यादा ही होंगे।
ओके, बट इट्स अ फेयर एनफ आर्ग्यूमेंट। बट
ओके, देर इक्वल।
ओके, हाउ?
तो we'll assign a natural,
Yeah, but how are you gonna assign a natural number? That's what I want.
I guess.
Wait, is my voice clear?
Yeah.
Yeah.
Okay, yeah. So you were telling me how are they equal?
We'll assign a natural number to each rational
Yes,
number.
yes, yes, yes. But how are you going to assign? That's what I want to know.
Uh, We can take random rational numbers and then maybe assign a natural number.
But I didn't do it this way ना to prove even numbers का जो set है जो even numbers total number of even numbers and total number of natural numbers are equal. I didn't do it by what you were saying. You are saying.
Um,
Okay, what if I say PN PN what do you like say PN Q belongs to Z plus.
we'll assign even natural numbers to the positive rational
No, no,
numbers.
no, no. I already said कि ये जो set है ये positive rational numbers का है. Are these two equal?
Um, no,
Okay. So I'll leave this as an exercise for you guys. I don't think we have much to like discuss now, but I'll say that I'll come again to our discussion on differential calculus. So I did not give any rigorous definition. I just told you guys we did work it out from scratch, and we were able to say that if this is our distance versus time graph, or maybe I should do it time versus distance versus time. Yes. So the slope is equal to the slope at this point A is equal to the instantaneous speed at A. We were able to derive this, or maybe you should say we were able to intuitively or and geometrically we were able to find this result out. I want you guys to reconstruct the proof at home, reconstruct the proof, maybe try to work it fair, uh, and I think yeah that's enough. What we can do is we can try to I'll try to tell you guys ki like let us take an example. We didn't do much example. We did some rigorous calculations at first, then we switched to graphs. Now let us try to work some things out algebraically. So suppose we have a function. I'm going to over the class very quickly. I think it's very late, and thank you guys for still staying. So let us say we have a function, say y is equal to x squared. Now let us like stick to it algebraically rather than going and diving into real world examples. So now what I want you what we want to find out is the slope at x is equal to say a. What is the slope? Why do we want to find the slope out? Because we already learned that it is very helpful. I mean, the slope, finding out the slope would help us find out the speed if we are given a distance versus time graph. And if we were given a velocity versus time graph, we would be able to find the slope. So this is why this part of calculus, this is where this part of calculus, the differential calculus actually helps us. I gave you a real world examples where we had to judge the race, judge the race that as who won the race, right? So we want to find out the slope at x is equal to a. How will we do it? First of all, we already visually found out that ये हमारा graph है. ये है x is equal to a, and y is equal to a squared, because हमारा function है y is equal to x squared. So now uh, what we do is our slope is actually equal to the limit of x tending to a, or I should say the limit of delta. uh, Now let's say यहाँ पे this is x is equal to a. Let us take a tiny nudge at a distance delta h. At a distance delta h. This is fairly more mathematical and more rigorous way of defining it, because we already were able to grasp and understand that how the slope was equal to the speed and all that. So let us try to rigorously define it. So we want to find the slope at this point. Take a point at a distance delta h, a tiny nudge delta h uh, from x is equal to a. So now, due to this tiny nudge, यहाँ पे x coordinate is a plus delta h, and so the y coordinate at c, y coordinate of c would be a plus delta h का square, a plus delta h का square, and y at a is actually a square. What we're gonna find out is the slope. Slope is actually equal to y2 minus y1 yc minus ya upon the x coordinate, which is delta h, right? The change in x coordinate. This is delta x. Is everything clear? I may be going too fast, but I think you guys can understand, right?
Yeah.
Okay. What is
Yeah.
yc? Yc minus ya. Yc is actually a plus delta h ka squared minus we are doing a squared. So it will turn out, do a mental calculation, guys, and it will turn out to be 2a delta h plus delta h squared divided by delta h, and we have 2a plus delta h. Okay, this is the slope of the line that passes through a and c, where c point is defined as by taking a tiny nudge delta h. Now to get the best possible approximation, or I'd say the exact slope of the line that passes only through A in its neighborhood, which is by definition called tangent, then our slope of tangent would be equal to the slope. This slope, I'll say this is, what do you say? I'll say this is f of, or maybe I'll say this is k, is equal to k. This is equal to k. This is equal to k as delta h tends to 0. And this means our slope of tangent would be equal to k because of the limiting process we're following, right? Because of the limiting process we're following.
Yeah.
And so I can say that slope of tangent, this is the slope of tangent, is actually equal to limit of delta h tending to 0. This is how you say mathematically that you are following a limiting process, right? Mathematically, this is a way to represent that you are following a limiting process. Limit of delta h tending to 0 uh, 2a plus delta h, which is equal to 2a. Because as delta a tends to 0, our slope will actually turn out to be 2a. Right? So,
Yeah.
so now for y is equal to x squared, the slope, the equation of slope is equal to 2x, is y is equal to 2x. So I've derived it, and I still suggest you guys to work it all out in your at your home. So I think it's enough for today, but there's one thing I want to talk about, that okay, we were able to find out the speed. It was distance upon time. What we did was we divided distance over time, and so it is basically rate of change, right? This is equal to the rate of change of distance with time. But if we were given, say, if we were given velocity, then how would we find acceleration? We would find acceleration by velocity upon time. This is how you find acceleration. So this is rate of change of velocity with time. This is acceleration. But suppose that you were given the acceleration. How would you go back to velocity? How would you go back to velocity? Do you guys have any suggestion?
We'd multiply the acceleration by the time taken to get the velocity.
Okay, but remember हमारा हमें इंस्टेंटेनियस एक्सेलरेशन हमें अगर इंस्टेंटेनियस वेलोसिटी निकालनी है, तो सो यू आर सेइंग कि वी मल्टीप्लाई द एक्सेलरेशन बाय द टाइम, राइट?
Yeah.
Okay, so suppose you have this graph of v versus t. This is v versus t. हमारा v क्या है? I'm making a tiny nudge of delta t. This is t, and this is t plus delta t. And ये जैसे जैसे delta t पास आता जाता है, it becomes the slope. Now you're saying कि we have the velocity, but we have the instantaneous velocity. तो अगर हमारे पास v instantaneous, अगर हमारे पास acceleration instantaneous है, तो हमारा डेल्टा टी तो जीरो हो जाएगा ना? तो हमारी वेलोसिटी भी जीरो हो जाएगी क्या? इज आर वेलोसिटी जीरो?
No.
क्योंकि हम तो डेल्टा टी को धीरे धीरे जीरो की तरफ रख रहे हैं.
हाँ.
So the thing is, the velocity, the delta t is never zero. We follow a limiting process and we say that delta t tends to zero, and then we say कि the slope tends to the slope of the tangent, and the slope of the tangent is exactly equal to whatever the value that we found, right? So we follow a similar method. हम क्या करेंगे, ये जो टाइनी नज है डेल्टा टी, और इस मोमेंट पे जो वेलोसिटी है, okay, we were given the acceleration and we wanted to find, okay, my bad, हमें acceleration given था, हमें velocity निकालनी है. तो acceleration given था, velocity comes out with the how do you find out the velocity? Yes. So हम इस tiny nudge delta t के बारे में बात करते हैं, और हम क्या करते हैं, we multiply this, essentially what we do is ये value delta t है, this is our acceleration, this is acceleration at time at t plus delta t, and जैसे जैसे delta t जीरो की तरफ टेंड करता है, ये पॉइंट भी इसकी तरफ टेंड करता है, एंड वी गेट अ वेरी थिन रेक्टेंगल, right? We get a very thin rectangle, and so we get a very you can say we get a tiny change in velocity which is equal to the tiny change in acceleration, or you can say which is there is no change in acceleration actually. जैसे जैसे ये पॉइंट इस पॉइंट के नियर आता है, हमारा एक्सेलरेशन ए आ जाता है, एंड दिस इज डेल्टा टी. So now, what we follow is we integrate this, and this is actually a topic for maybe we can take it in the next class, and this is maybe you can ponder about this. So I hope everything is clear till now, and I'll over the class here only. And thank you for staying. Bye. Okay.
Bye.
Thank
Thank
you,
you.
guys. Goodbye.
Thank you, Suhail. Bye.
Good
Bye.
night. Bye. Goodbye.